Let's jump right into this explainer. Look, if you've ever built an AI agent, you know the exact heartbreak I'm talking about. You spend hours, literally hours, crafting the absolute perfect system prompt. The conversation is flowing beautifully, the responses are incredibly smart, and then, right around 20 minutes in, the bot completely forgets who you are. It asks you a question you already answered 10 messages ago. It's incredibly frustrating, right? It just completely shatters that illusion of intelligence. But today, we are going to fix that by breaking down exactly how to architect a true production-ready intelligent memory system for your LangGraph chatbots.
We're going on a journey to cure forgetful AI once and for all. Here is our roadmap. First, the chatbot memory problem. Second, short-term memory fixes. Third, building long-term memory. Fourth, optimizing the summarization loop. Fifth, avoiding the volatile memory trap. And finally, number 6, setting up permanent storage checkpointers.
Part 1. The chatbot memory problem. Hitting the wall.
To actually build a real memory architecture, we first have to fully understand the core limitation of every single large language model out there. You see, an AI doesn't inherently remember you. It doesn't have a biological brain. It only knows what you explicitly package up and send to it in the current prompt. And that brings us to the token limit, or the context window. This is the strict maximum number of words or tokens an LLM can process in a single prompt before it either fails entirely or incurs massive API costs. Think of the LLM's context window like a goldfish bowl. You can only pour so much water into that bowl before it inevitably spills right over the top. The issue is, every single time you and the AI exchange a message, that bowl gets a little fuller, your history gets longer, and because you're charged per token, your API bill starts creeping higher and higher with every single back and forth.
So I really want you to think about this. What happens when our chat exceeds 100 messages? Or 1,000? If we just keep passively appending every single message into the prompt history and sending that massive block of text to the AI every single time, what is the inevitable outcome? Well, eventually, you hit that token wall. Best case scenario? The model becomes incredibly slow, completely bogged down by reading a novel's worth of text just to say hello, and it becomes ridiculously expensive to run. Worst case scenario, the entire system crashes, throwing a fatal context overflow error right in your user's face. You absolutely cannot pass the entire raw chat history forever.
Part 2. Short-term memory fixes. The amnesiac bot.
Since we literally cannot send the entire chat history forever, you might be thinking, well, what if we just send the most recent stuff? This leaves us with the ultimate developer's dilemma. You basically have two bad options here. You either crash the system and go broke by forcing the AI to remember everything, or you aggressively take a pair of scissors to the conversation history. Now, LangGraph actually makes it very easy to trim messages. You can easily set up a filter function to just pass the last 2 or 3 messages to the LLM and drop everything else. And yeah, it definitely saves tokens. But as we'll see, you're really just trading a technical problem for a massive user experience problem.
If you go with that simple trimming method, the bot inevitably forgets crucial basic information. The source material has this brilliant example of how badly this breaks down in practice. Imagine a user logs on and their very first message is, "Hi, I'm Lance." The bot says hello, and then they chat back and forth about sports, the weather, whatever, for about 5 minutes. Then Lance asks a simple question. "By the way, what is my name?" Because the system brutally trimmed the history to just the last 2 messages to save tokens, the AI just blankly responds, "I have no access to personal information." It literally deleted Lance from its memory.
Part 3. Building long-term memory. The elephant's brain.
To solve this goldfish memory issue without blowing up our token costs, we need a much smarter approach. We need the bot to understand the deep past of the conversation, but without forcing it to read a raw 10,000-word transcript every single time you hit enter. This is where we introduce the hybrid long-term memory formula. By combining a running summary with the immediate short-term history, we give the AI perfect contextual awareness while keeping our API costs beautifully low. Instead of just deleting old messages into the void, we use the LLM to compress them into a tight summary. Then, when a new message comes in, we pass the LLM that compressed summary plus the exact verbatim text of the last couple of messages. It gets the deep context of the whole relationship, but it also has the immediate, short-term context of what you just said 2 seconds ago.
Part 4. Optimizing the summarization loop. Okay, so let's dive right into the actual LangGraph logic of how this summary is generated dynamically. Because you're probably wondering, how do we keep this summary up to date as the conversation naturally flows and changes? Well, this logical loop is the core of our solution. If it's the very first time we're summarizing, we just ask the LLM to create a new summary of the chat so far. But if a summary already exists from earlier, we pass that old summary along with the newest messages, and we explicitly prompt the LLM to extend the summary by taking into account the new messages. It's totally brilliant because it creates a continuous rolling compression of knowledge. The bot is effectively writing its own diary entries in the background. It reads its old diary, looks at what happened today, and writes a new, updated entry, so it never ever loses the overall plot of the conversation.
But hold on. We definitely don't want to run this heavy summarizer after every single hello or short reply. That would be massive overkill and burn through our API credits in no time. So, we introduce a conditional edge. Think of a conditional edge like a bouncer at a club directing traffic based on a set of rules. In LangGraph, we use a custom function, often called shouldContinue, to route our workflow. It looks at the conversation state and decides, okay, should I run the heavy summarization node right now, or should I just output the AI's response and end the cycle for now?
And that brings us to the magic number 6. We set a strict cost-saving threshold. We wait until the conversation hits exactly 6 messages before we let that conditional edge trigger the first summarization loop. Why 6? Because summarizing a 2-message chat is just burning API credits for absolutely no reason. By keeping a sliding window buffer and waiting for 6 messages, the initial rapid-fire conversation flows instantly without any background delay. Once we cross that specific line, our routing function kicks in and quietly generates the first compressed summary.
Part 5. The volatile memory trap, brain freeze.
So our system is highly intelligent now. It's context-aware. It's optimizing our API costs. We've built a beautiful, compressed brain for our bot. But it has a fatal flaw if we stop building right here. Because you really have to ask yourself, what happens when the server restarts or the environment disconnects? Imagine you're feeling like a total genius, you're testing your bot locally, it remembers your name perfectly, it remembers your favorite sports team, and then your Wi-Fi drops, or you refresh your Colab notebook. What exactly happens to that beautifully crafted, continuously updated running summary?
Boom! It triggers a total data wipe. You see, in-memory storage is highly volatile. When you disconnect, all those state variables sitting in your computer's RAM are wiped entirely clean. It's exactly like playing a massive, complex video game for 5 straight hours, building up all this progress, and then turning off the console before finding a save point. The state goes strictly back to 0. If Lance asks, "What is my name?" right after a quick server refresh, the bot is right back to having total amnesia. Now, this is fine for local testing, but it is an absolute disaster for a production app where real users expect the bot to remember them tomorrow, next week, or even next year.
To escape this trap, we absolutely must anchor every single conversation to a unique thread ID. Think of a thread ID like a specific user account ID, or maybe a digital filing cabinet drawer with your specific name on it. It is exactly how you can open up the ChatGPT app on your phone 3 days later, tap an old chat history on the sidebar, and pick up right where you left off. The thread ID is the master key required to retrieve that specific user's running summary from the void.
Part 6. Permanent storage checkpointers, immortal memory. We have our unique thread IDs, we have our hybrid summary logic dialing in the context. Now we just need an external vault to keep it all permanently safe. Enter the checkpointer. Instead of keeping the state in fragile memory variables, a checkpointer safely writes our summary and our thread ID directly into a database. A checkpointer does exactly what it sounds like. Every time the graph executes a step, it takes a literal, hard snapshot of the state. It bundles the current message, the latest summary, and that unique thread ID, and saves it externally. So if your server crashes in the middle of the night or a user logs off for a month, it doesn't matter. The next time they send a message, LangGraph just queries the checkpointer for the last known snapshot tied to their specific thread ID, loads it up, and resumes the conversation perfectly.
And what makes LangGraph absolutely incredible here is how easily it lets you scale this permanence. You can start small. For local development, you just import SQL Saver. It points to a local file right on your machine, and LangGraph automatically generates all the tables and schema you need to store your snapshots completely behind the scenes. But when you are ready to launch and scale to thousands of real-world users, you don't have to rewrite your entire application. No way. You simply swap out that one single line of code for Postgres Saver, paste in your production database URL, like a serverless Neon console, for instance, and suddenly your memory infrastructure is fully enterprise-grade. It's that easy.
So there you have it. You now have the complete architectural blueprint for immortal, cost-effective chatbot memory. You no longer have to choose between going broke on API token costs or having a bot that forgets its own users' names. By leveraging persistent checkpointers, unique thread IDs, and a smart, rolling summarization loop, you can build AI agents that feel incredibly lifelike, deeply personalized, and endlessly capable. So here's my question for you. How will you apply this hybrid memory model to supercharge your next AI application? Think about it, keep building, and until next time, keep exploring.